Okay, this is chapter 10, lesson 5, which we didn't get to in class yesterday, and it's just about finding areas and perimeters of different kinds of figures. And so we're just going to be reminded of those different formulas. When you have this first picture is basically just a triangle, a rectangle, and a semicircle attached together, and we want to find the area and the perimeter. So the way we do that is, first of all, we need to remember what all the formulas are. And so first of all, we need to remember that the area of a circle, area of a circle is pi r squared, where r is the radius. The circumference of a circle is equal to 2 pi r, where r is the radius. The area of a rectangle, I'm sure you know, is length times width. The area of a triangle is base times height over 2. So we need to know those things so that we can figure this out. Alright, so first of all, I'm going to drop an altitude for the triangle because you have to know the height, and the height means perpendicular height from the base up to the top. Okay, and so I know that this is a right angle because that's what I made it to be, and this is the height of the triangle. So to find the height, I just look at this rectangle because I know this is a right angle and this is the height. So this is 2 radii of the circle. It's the diameter of the circle. It goes right through the center. So the height of this rectangle is 4. Alright, so I know that the width of the rectangle is 5. So this piece that's left over here, since the whole thing is 8, I know that this part of it, just this part, is going to be 3. So the area of the triangle is 3 times 4 over 2, base times height over 2. The area of the rectangle is 4 times 5. And then I'm going to add the area of the semicircle, which is pi r squared over 2. So pi times r squared over 2. Alright, so that's everything. That's the triangle, the rectangle, and the semicircle. So 12 over 2 is 6, that's 20, and then 4 pi over 2 is just 2 pi. So that's 26 plus 2 pi. And on the SAT, they might just leave the answer like that, but you could punch that into your calculator. And then to find the perimeter, we know we don't know the circumference, and we don't know this part right here, but we know that this triangle has legs 3 and 4, so the hypotenuse, since it's a right triangle, we know the triangle 3, 4, 5 is a right triangle. So 3, 4, we know that's 5. That just happens to be a triangle that we do know. Alright, so we can add up going around for the perimeter. We can start here. We've got this whole side here is 8. And then the hypotenuse we said is 5. The top is 5. And then we've got to figure out the circumference around the circle. And we only need half of a circumference because it's a semicircle. So the circumference of a circle is 2 pi r. So it's 2 pi times r over 2. So that's 8 plus 10 plus 2 pi. So that is 18 plus 2 pi for that circumference. So that would be the area and perimeter of that shape. Okay, now we have a trapezoid. For a trapezoid, to find the area of a trapezoid, what you basically do is you take 1/2 times the height, and then you multiply that by the sum of the bases. In a trapezoid, these horizontal sides, the sides that are parallel, are called bases. Alright, and the reason that we do that is because, oh goodness gracious, that looks like a nightmare. If I could draw a straight line, let's see, can I do that? Insert a shape, a line, let's see. if you break the trapezoid into two triangles, what you're going to have is base times height over 2 for the bottom triangle and base times height over 2 for the top triangle, which ends up giving you the height. That's just height over 2 times the sum of the bases. Base times height over 2 plus base times height over 2. So this is the kind of the formula for the area of a trapezoid. It's just base times height over 2 plus base times height over 2 for the two triangles that you would get if you split it in half. So since I know that the height is 4, that's just 4 over 2 times 24, which is 2 times 24, which is 48. So that would be the area of the trapezoid. And then to find the perimeter of the trapezoid, again, I'm going to drop altitudes down so that I can see these two right triangles on the ends. And I gotta do that again. Okay, so I'm doing this because I'm going to have to find the length of those hypotenuses so that I can figure out how far I've got to go on the sides. Okay, so since this whole bottom is 15 and this whole top is 9, and I know that this is 4, let's see, is that going to help me find those sides? So this is 9, then yeah, there's no way for me to know what those ends are. So I can't find the perimeter of that picture, and I don't know why I put it on there as if you could, because you can't. So just don't worry about finding the perimeter of that because you can't do it with that information. Alright, so the perimeter of this figure, all angles are right angles. This is a situation where you might say, well, how am I going to figure that out because I don't know all those little pieces? And you don't have to know all the little pieces to find the perimeter, because as long as you know how long the sum of the little pieces is, then you're good. So this side is 14, so if I'm going to find the perimeter, that's 14 plus 10, so that's this side plus the bottom. And then all these little vertical pieces, this, and this, those add up to 14 because that's just the total sum of this side. So I don't need to know what each one of them is. I can just add it up and that's 14. And then the horizontal pieces, if I get a different color, I can I? Yes, I can. Blue. Okay, the horizontal pieces that I don't know their lengths, they all add up to 10 again because it's all the way over. So that's another 10. So that's all you have to do for that figure to find the perimeter. You don't have to know the little pieces, you just have to know what they add up to. So that's 28 plus 20, which is 48. Okay, this bottom one is just, we're trying to find the area of the shaded region. When you have a picture like this where you have a shaded part, what you have to do is take the area of the whole thing and subtract the piece you don't want. Alright, so the area of the whole rectangle is going to be 9 times 8. That's the whole rectangle. And then I'm going to subtract the white triangle because I only want the red part of the picture. So base times height over 2 is the area of the triangle. So base times height over 2. So that's 72 minus 18 over 2, which is 9. So that's 63 for the area of the red part. Okay. In the figure below, the shaded region is constructed only of horizontal and vertical lines. That is, all the angles are right angles. What is the perimeter of the shaded region? So this is kind of like the one we did before, where you've got all these little pieces and you don't have to know what they are. So we're just trying to find the perimeter of the shaded part. Okay, so we've got 20 for the bottom part of it, and then we've got 15 going up. And then when we walk all these horizontal pieces all the way, we're going to have to walk all those horizontal parts, and that's all going to add up to 20. And then we're also going to have to do the vertical parts, and they, again, all add up to 15. Okay, so even though you don't know the lengths of the little pieces, it doesn't matter because they add up to the same thing as the 15 and the 20. So that's 40 plus 30 is 70. Okay, and then this last example, if the circle with center C has an area of 16 pi, what's the area of the shaded region? Okay, now this is a little more tricky. You have to figure out, first of all, the area of the piece of pie here, the whole piece of pie. Alright, and to do that, that's just 1/4 of the circle because that's a 90-degree angle, so there are 4 of those in the whole circle. So it's just 1/4 of the circle, which is pi r squared. That's the area of that whole piece of pie right there, including the shaded part and the triangle. Alright, so that is, they told us that the circle with center C has an area of 16 pi. So the area is pi r squared, and they're telling us that's 16 pi. So that tells me that r, the radius, must be 4 because I'm squaring r to get that 16. So the radius of this circle must be 4. That's why they gave me that information. Okay, so I know the radius is 4, and I'm just trying to figure out, well, I didn't even need to figure that out at this point because they told me the area is 16 pi, and so this piece of pie is 1/4 of that. Okay, so the area of this whole piece of pie is just 1/4 of the total area, so it is 4 pi. So 4 pi is the whole piece of pie. I'm going to subtract the white triangle because I don't want the whole piece of pie, I just want the shaded part. So I'm going to subtract the area of that white triangle, and that I know now because I figured it out before that the radius is 4, so the sides of that triangle are 4, so that's 4 times 4 over 2. That's the area of that white triangle, so 4 pi minus 16 halves, which is 4 pi minus 8. So that would be the area of just the shaded part. Okay, so we took 1/4 of the whole circle, that's what the piece of pie here is, and that was 4 pi right here. And we subtracted the area of the white triangle, which was base times height over 2. And we figured out the radius of the triangle by knowing that the area of the triangle was 16 pi, so the radius of it must be 4 because pi r squared is the area. Okay, so that is lesson 5 on chapter 10.